So we're back. Now, if you remember start plus total change, that's essentially what we're going to need here, okay? Because we have the derivative and we have a starting value. But the problem is our starting value is actually at the end of our interval. So let's just revisit start plus total change, okay? So if you remember, f of b is equal to f of a, which is your starting value, plus the integral from a to b of f prime of x dx, okay? Or it could have been capital, and then that would have been lowercase. But this right here is the total change from this value to this value. Now, the interesting thing is usually b is greater than a, so we would start from a lesser value and be going to a greater value here. But in this situation, our b is 6, and our starting is 8. So that would be like our a. So when I do this, I'll say f of 6 is equal to what the starting value that I know, f of 8, plus the integral from a to b. So a in this situation would be 8 to 6 of f prime of x dx. Okay, now since the 8 is greater than 6, if you remember properties of integrals, we can switch our limits of integration around, and then that just means that we have to subtract. So then this is going to be f of 8 minus the integral from 6 to 8 of f prime of x dx. Okay, so f of 8 is 4 minus the area, that would be the total change, from 6 to 8. So if I go back to my graph, this is x equal, this is x equal to 6, this is 8, and that is an area of 7, and it's positive. But since we're going to be subtracting that, it's going to be this. And so that value is -3, okay? So we've got this value, we've got this value, and now we want to do the same thing with f of 0. So again, I'm going to start off with f of 8 is equal to, and again, I could do plus 8 to 0, or we know that we're going to just switch it around, and it's not equals, it's plus. Sorry. We know we're going to switch it around, so actually minus 0 to 8 of f prime of x dx, which is equal to 4 minus, now let's find out the total area from 0 to 8. So if I look at the total area, I've got some work to do here. Let's see. It's 2 plus 6 minus 3, because that's under the x-axis, and plus 7. It's 2 plus 6, 8. 8 plus 7 is 15. 15 minus 3 is 12. All right. So the total area from 0 to 8 is 12. So I'm going to do 4 minus 12, which is -8. And so now we have 3 values to compare. We have f of 0, which is -8. We've got f of 6, which is -3. And let me make that down. And we've got f of 8, which is 4. And the question again was asking for the absolute minimum value. And so between all 3 of these y values, the lowest value, the absolute minimum, would be that one right there. And so the absolute minimum value, would be f of 0 equal to -8 on the closed interval of 0 to 8. And that's it.